Good evening, ladies and gentlemen. Today I want to show you one of the other PCBs I designed in the last year. This one is the Pixel Digit PCB. You most probably directly get what it is about. It is a PCB to design a custom 7-segment digit, or even if you combine multiple of these, a 7-segment display. Before I tell you more about this PCB, again, I want to tell you why I thought it's time to design a PCB like this. Because there is a predecessor of this. Before I started with the PCB, I had a simple 3D printed housing that looks like this, with slots in here. I think you get it. And in these slots I put these, or in the past I put these simple WS28 LED strips. In each slot 2 of these LEDs, glued them in there with hot glue, and when they were glued in there I had to solder the different wires, the connections, while these LEDs are already glued into the housing. And that's one of the huge main reasons why I thought it's easier, or it's needed to build a PCB that makes you get rid of this work. Because that's a pretty fiddly work you have to do here, because you have, I think I can show you here, you have these little slots where the wires had to go through to the next section. Then you had to solder it here, LED strip goes over here, you had to route the wires again through the little slot, had to solder it here again, and that takes you at least some hours and not much fun. I thought there must be an easier solution for this, and that's why I started to design the Pixel Digit PCB that makes this job a lot easier. So therefore I designed the PCB in this typical 7-segment shape and populated it with SK6812 LEDs. This one here, but you can see already that it is a side LED, so it does not shine in the upwards direction, it shines in the side direction. The reason for this, and the big advantage, is that you have a much better light distribution this way, because the light does not go directly towards the acrylic sheet or the transparent 3D sheet, where you can see these light spots. It has to go in that direction, is reflected multiple times, and this way the light distribution is much better than when you use LEDs that point in the upwards direction, like I had it in this case. So here you can easily see, okay, there's one LED and here's one LED, and the light is not that nice distributed that you create an illusion of one segment LED. So that was the idea, that one segment looks like one LED, and with LEDs in the upwards direction it does not work that good. You have to care a lot about light distribution, and that's not that easy. So another reason to switch to this PCB with the side LEDs. Beside these side LEDs there are ESP01F. That's basically a very small version of the ESP8255, which is again based on the ESP6288. The big advantage of this one is that it has an integrated flash and therefore saves a lot of PCB space. Additionally, this one is, as far as I know, the smallest ESP8255 that you can get right now. That's why I used it here, because it has a width of 11 millimeters only. So it fit perfectly here on this very narrow PCB. A little advantage is that it does not have the integrated antenna, so you have this UFL connector where you can connect a Wi-Fi antenna that you of course have to store somewhere in the housing, but right now there are a lot of different antenna shapes available, so that's not a huge problem. Beside this, here are the usual buttons for reset the ESP or for put it in programming mode, but that's actually only needed if you don't populate the CP214, that's the USB serial bridge. So if you have populated everything properly, you can also program the ESP via the USB-C port. That works this way, that these CP214 simulates a serial device on the USB side, and on the side to the USB it simulates a serial connection. That's a pretty cool way or common way to interface a lot of microcontrollers. You see it also on many Arduino boards. Yeah, I already mentioned the USB-C port. That's a cool way to power devices today, because you can power them with up to 15 watt when you use the normal USB-C standard. If you switch to a more intelligent power delivery standard, then there's today even up to 100 watt possible, and they're already working on a new standard to supply up to 240 watts to a USB-C port. That's pretty cool, and I'm curious to see where this connector goes through in the future. And that's mainly all of the basic circuit of these pixel digit PCB. But of course there's some more. Here you have a solar pad that is located on a little cutout where you can connect the BME 280. That's I2C sensor for temperature, humidity and air pressure. So you can also use this to measure the environment data at that location where you put these pixel digit device. Another member on the I2C bus is the MPR121. That's also a controller I use a lot on my other PCBs. It's a capacitive electrode controller, so you can connect up to 12 electrodes, capacitive electrodes, to this integrated circuit. The cool thing about this is that you can connect electrodes that you don't need to directly touch them. So for example, you can put a copper foil or another metal foil behind a part of the housing, and if somebody touches the housing from the other side, it's detected by this IC, communicated via the I2C bus to the ESP, and this ESP can react to it, for example, switching off the light, changing the color, changing the brightness, whatever you like. Yeah, that gives you many possibilities if you're interested to integrate some user interaction into your PCB or in your project. Here at the top we have a solder pad for a TSL2591. That's more or less a simple brightness sensor that gives you information about the current brightness in the room. So that's a pretty cool thing to dim the LED matrix brightness in case the room brightness is pretty low, so that you don't start to dazzle people in the room by a high LED matrix when the environment brightness is pretty low. Also a good thing to save energy. Of course, one pixel digit alone is not enough, because this way you can only display numbers from 0 to 9. But in most use cases you want to display more numbers, or for example even time. And therefore you can use another pixel digit PCB. You don't need to populate it completely, you just put the LEDs on it, and then you have this, here it's called L in and L out pins, where you can put in data and you get data out. So in the end, you connect these pixel digit PCB like any other NeoPixel or WS2812 LED pixel stripes. Like a shift register, they are connected in series, and you can push the data from the ESP on the first PCB through all the LEDs, through the next pixel digit, through the next pixel digit. I don't know, however you like. I think it's possible to interface up to 512 LEDs this way. So you can build very, very huge LED displays with these pixel digit PCB. But of course, this PCB alone is not that suitable for your 7-segment display. Therefore, I created these 3D printed housings that look pretty similar to the original housing. So the size and shape is of course very close to the first version. But here we have some, a lot of stringing, of course, sorry, but also some cutouts where you can put the PCB inside. It more or less snaps in and stays in. You have access on the button, the USB-C connector. You can connect the cable through it. Already have the shielding around the LEDs. It's this way that the light glows only to the front. Now you could already, I can already show you, connect these PCB to a USB-C power. here's just an example sketch on it to show that the LEDs are working and they are doing this rainbow simulation. Yes, but of course this is not enough, because you can still see the bare PCB and it doesn't look that nice. You don't have any light distribution. Therefore I designed these little acrylic sheets that are cut with my milling machine. You can put them in here so that you have a bit better light distribution by the LEDs. And if you switch it on now, you can already see that the light distribution is much better than before. Still a bit spotty, so you can see where the LEDs are. That's not that nice, not what we wanted. So I switched from milled acrylic glass to these 3D printed ones. Here's a failed one. I had the black filament in before, so of course it's not that nice. But I have one complete housing prepared with this, so they are not this translucent like the acrylic sheet. Again, here I put the pixel digit PCB in from the back, snaps in. As soon as I connect the power, it glows up, and you can already see, even in this bright light, that the light distribution is much better, and that the single segment looks closely like it's one LED, and that gives you a nice 7-segment design and effect. And that's a pretty cool way to simulate a 7-segment display from my point of view, of course. Yeah, that's it so far about the pixel digit PCB. I hope you liked it. I will put some more information about it below the video. And if you like the video, leave me a comment. If you don't like it, leave me a comment as well, but tell me what I should do better. And have a nice day. Bye.